I'm Guy M0GUY, for those that don't know, I'm for the camera. I've been doing 3D printing for probably close to 15 years now, maybe a bit longer. I built my very first 3D printer from scratch in the office to try and hide it from coming in from the wife. So it came in pieces and slowly assembled this monstrosity, designed the circuit boards, wrote the software, did the whole lot because no one else was doing that. And lived with that for years, but had the problem of bed leveling and prints not coming out quite right and all sorts of problems. About 18 months ago, I decided I'd had enough of using that printer. Time was to see what the modern printer's capable of. And I ended up with this one, which is an Anycubic Kobra 3. It's about £300 for that and this. So it's not an expensive investment. From there, a whole world of opportunity opens up because you start making your own things. Now, first of all, you think, oh God, how am I going to design something in real space? I can barely draw a picture on a piece of paper, right? Well, there are websites that will help you with that. That loads of people have already designed things. You can go to loads and loads of websites, Thingiverse, MakerWorld, and just download their images. My daughter has been collecting, she's discovered McDonald's Happy Meals with a little toy, which was the Friends characters. And she loves Friends, so she's been going to McDonald's and collecting all these toys. And McDonald's actually did the nice thing and would give her the right toy that she wanted, rather than going, no, that's a special one, you have to keep coming back and getting more food. They would give her the right toy. And so she ended up with the collection. So I'm sitting there going, well, I've watched Friends, and I know that they all sit on a red settee in the cafe. I went on to MakerWorld, found somebody who'd already designed the red settee for these characters, and just sent it to my printer and said, print this out. And a day later, I had a red settee in plastic ready for my daughter to put her characters on. So again, easy, simple things to print out. At the moment, just ignore it. It's making a bit of noises because it's calibrating itself. Every time you move it around, you need to recalibrate. We're talking fractions of a millimeter between each layer here. So if we're off, the layers won't stick together and the print will come out and be horrible. So it's much better just to calibrate every time. So what it's doing at the moment is working out what the resonant frequency is of where it's sat. So on the table. So it's going to get faster and faster and faster until it can figure out how to make it move. I used to do this at university to one of our, we had some new hard drives back in the day when hard drives were huge. And they put it on one of the servers that we had access to as computer science team. And we wrote some software to make the hard drive walk across the room, made it resonate, march across the room. Needless to say, we wrecked the hard drive. And we were not the best pleased. Anyway, okay, so what I'm going to talk about is some of the things that we need to know about in order to make 3D printing work. So what is 3D printing? Well, it's an additive manufacturing, as opposed to CNC, where we cut things away from a model. So you start off with a block of wood or a bit of aluminium and you start milling things out from it. In 3D printing, we're actually adding things. And what we're doing is printing a continuous layer of plastic all around to build up our model. We can actually print all sorts of things now. So we can print in concrete. You may see people building their houses in concrete, 3D printing houses. 3D printing food. Is another good one. So yeah, anything goes. One of the cool things about plastic printing is these are all PLA. So this is just a very cheap plastic to print. 1 kilogram costs about £10 of plastic. So it's really, really cheap to print and test stuff out with. But I have, not here with me, but I have another reel which is conductive. So I can actually print conductive lines. So if I'm building, what I'm working on at the moment is a Morse key, I'm actually putting the wire in the plastic, so there'll be no conduction through. Anyway, so we're laying down a layer at a time and building up. Now, what we need to do is we need to design what we're going to draw. So we need a CAD software to draw out the picture of what we're going to make. Then we convert that picture into what's called an STL file, or a 3MF file. And then that file is converted using a piece of software called a slicer, which is typically specific to the printer. There are about 4 different slicers, but they have a understanding of how the printer operates. So the dimensions of the printer, how hot the head can go, and so forth. And that converts into finally a thing called G code. And I'll show you some of these in a minute. But it's the G code that describes how to move the printer head around and excrete the plastic to make the object that we're looking for. So each bit of G code that you get is specific to the printer. Yeah? So if somebody gives you a bit of G code and says, here, print this, it ain't going to work unless they've got the same printer you have. So if you are sharing things, you want to either share the original model or the STL file, and then you can make it print. So we're going to do what's called fused deposition modeling. So we're melting the plastic, squeezing it through a tiny, tiny hole, in this case 0.4 of a millimeter hole. We can go down to 0.1 of a millimeter. This printer is quite painful to change its head. I have another printer, I have a Bamboo Labs printer, and the heads all line up on the side, so it can just pick its own head that it wants to print with, and that will go down to 0.1 of a millimeter for each one. But as you reduce the size of the print, you increase the duration of the print. So, because it's obviously got to do more covers to get the same place. So most print jobs you will see are going to be 0.4. That is the most common print size you'll see. So we have different types of printing. We have what we call a bed slinger, which is one of these. So the print bed moves in either X, Y, or Z. In this case, this is just moving in the Y-axis, and the printer head is going to move in the Z-axis, up and down, and in the X-axis, left and right. My first printer, the print bed actually went in X and Y. So the print bed was doing this all the time, which was quite entertaining and very, very noisy. The other option you might find is the print head is the print prints upside down. So the bed goes down. The other ones are these delta ones where the head actually is on strings and it's just moving, the head is moving in all directions, X, Y, and Z at the same time. Very, very fast, but boy, is it hard to calibrate and get it working because you've got all of these bits of ropes going down, dangling this head around. Different types of prints. So we can use resin printers as well. So that's where we actually have a vat of resin and we shoot a laser or 2 lasers into the resin. Where the laser hits, it cures, and then it slowly again builds up in layer a layer, and eventually you get this model. Resin are very, very good for high quality prints. So if you want something absolutely minusculely detailed, so if you're printing out, what's it called? Warhammer models and things like that, then it's great for that because you get real precision detail. They often use it in medical as well. So if you've got teeth molds for braces or anything like that, it'll be resin printed undoubtedly. You can achieve very similar effects on these type of printers by putting the finished product into acetic acid baths, basically super glue. And if you put it into, it dissolves in nail polish remover. I can't remember what it's called, acetate. So you can put it in acetane baths, but it's quite dangerous because you have to warm up the acetane and things go. But then what it'll do is gently melt the outside and you get a nice shiny finish. Or you just put a blowtorch against it and then it'll get off all the rough edges. But don't hold it there for very long. So there are tricks, and people are playing with making them high quality print jobs, so it is possible. A couple of other ones there to play with, but these ones get more expensive and complex the way you go. So just doing a ink print is by far the easiest. So we start off with the design. I'm going to talk about 2 different design models, predominantly OpenSCAD and FreeCAD. OpenSCAD is the one I learnt 3D printing on, and it's a programmatical language for designing a model. So you can say cube, bang, and then it'll draw the cube at those dimensions, and then you can say, right, remove that bit there, and I want a circle here and a sphere here or whatever, and build up the model that way. But it's a programmatical language to do it. FreeCAD, graphical. So you just draw a square and go extrude that up 5 mils, and bang, it does it. And then you say, right, now make some holes there, there, and there. And again, you build it up from that. I love the free stuff because I'm not paying for it. But both are very active in their development. I'm playing with FreeCAD at the moment, so I'm not an expert in FreeCAD, but I have found plenty of bugs with it. So I end up falling back to OpenSCAD. Again, because I've been using it for so long, I can knock out models fairly quickly. Either of those will then export in this STL file format, which is a highly portable format. So it doesn't matter whether I developed it in OpenSCAD or FreeCAD, or there's a web one, Tinkercad, which is again free to play with. All of them will export out as an STL file. So it's a very portable file. And then we send it to our slicer. Often you get the slicer as part of the software that comes with the printer. But interestingly enough, they all have their derivatives into 3 fundamental slices, which is Cura and Orca, and one other, I can't remember its name now. And you can get those ones as open source, and then modify it to your heart's content. They've all got the same functionality. And then finally, we send it to the printer. Now, typically, if this was all in my house at home, the printer is on the Wi-Fi. So I can sit and just push it to the printer and say, off you go. And I usually do. So as I say, I've got 2 of these sitting next to each other. And so I'll send print jobs to both of them at the same time and just let it get on with it. And wake up the next morning and lo and behold, my print jobs are finished. For example, I print out 6 of these at a time, 3 in a row on each printer. And they print that way. So the text is on the ground, and so it's going to print that out, and that's why that's flush and slightly textured, because it picks up the texture on the plate here. That will take 7 hours to print 6 of those. So it's not a fast print. But you can come up and have a feel of these. They're fairly high quality prints. I could, as I say, finish them off with bars and things, but to be honest, I think they're perfectly fine as they are. They feel solid and definitely supporting enough. So we tend to leave those alone. But yes, it's not necessarily a quick job. Now, some printers, this one included, have their regular mode, but they also have a sports mode where the print does go faster, and so you can actually accelerate it. So if you are doing prototyping and you're not too fussed about the finished quality, you can stick it into sports mode and it'll up the speed by 25-50%, and it just throws it around. So transfer it by all sorts of means. Tonight we're just going to use a USB stick. So I'm just going to copy the G code onto a USB stick. There's a USB port on the front of the printer, and in this one we've got a nice little touch screen, and so we can actually drive it all through the touch screen. In this case, what happens is it copies the code into its own little memory, and then actually once it's got it there, you just say print. But what it also means is if you want another version of it, you just go print again and just keep going to your heart's content. So for OpenSCAD, hopefully you can see that. As I say, it's a scripted language. So here we're saying draw a cube that's 30 millimeters by 20 millimeters by 10 millimeters. So X, Y, Z, so 10 millimeters high. Then we're saying move this next section by 15 millimeters. So move it in 15 millimeters from the edge, 10 millimeters from the top edge, and then down -1, and then put a cylinder that is a height of 12 millimeters and a radius of 5. And because we've got this wrapped in a difference, what we're saying is, here's a cube, and now take out a hole in these coordinates that's that. So the hole is higher than the the height of the cube, because the cube is only 10. So we've gone down 1 below where the layer of the cube is, and above by, well, equivalent 1. So we'll end up with a cube with a hole through the middle. And that's all you do, and you just keep rinse, repeat. So we have these standard models. We have cube, sphere. We can do polygon, so if you do want to do a random shape, you can just describe it as a polygon and do that. But 99% of the time, you can describe everything in cubes and spheres and other standard models. And we have difference, we have union, and we have another one called hull, which is kind of interesting. Hull, if I put a cylinder here and a cylinder here, and then hull it, it will actually fill in the space between the two, and I'll get rounded corners. So I can make a nice rounded rectangle just by describing, well, I'll actually put 4 cylinders, one in each corner, and say hull it, and then I'll end up with a nice curved surface to play with. But one of the really cool things about OpenSCAD is because it's programmatical, I can have functions, and I can have ifs and loops and all sorts of other clever tricks. So here, I can make, what we're going to do today is build a badge, so a little name badge, and I can set a variable, what the text I want on the badge is, the dimensions of the badge, and then in my description of how to draw the badge, I can actually just use those variables. So again, makes it very dynamic. So if I want to make a bigger badge, I just go and change it in one location, and lo and behold, we get a bigger badge. Or if I want to change the name on the badge, easy to do. FreeCAD is a GUI version. So again, what we have to do is draw it on the screen. Now, the way FreeCAD works is you work on planes. So you have a plane, and you create a sketch on the plane, which is basically a description of a piece of paper. So you're describing it in 2 dimensions, and then you extrude that 2 dimension up or down, and then lay it onto surfaces. So you can build up very complex models very simply just by describing the surfaces as you see them and extrude them up. Again, you can actually script FreeCAD. So you can, it's one of these pieces of software that clearly has been developed by engineers with hope that engineers are going to use it. And so it's got every single bell and whistle you could possibly imagine in it, which, one, yay, it's got what I want, that widget that I want to do that only one person in the world ever asked to do. But boo, it's got loads of people helping with it, which means there's lots of bugs in it, or can be, lots of issues with it coming through. So swings and roundabouts in it, but it can be very, very powerful, and it is very active. So you might download and install it today, and by tomorrow morning there'll be a new version out. And just keep iterating the version numbers. OpenCAD versus FreeCAD. You can't really compare them because one is programmatical and one is graphical. So it's really up to you which way you prefer to work. I've only ever really worked on command line interfaces. In my entire life, I only ever work in command line. So program software is right down my street of how I like to operate. Whereas many other people come from a graphical feedback, in which case FreeCAD is the way to go. Or Tinkercad. I mean, there's loads and loads of people playing things on Tinkercad as well. So the slicer takes that STL file and basically slices it up into lots and lots of little layers. So every single layer is however high we want that layer to be, from 0.1 mil to typically 0.3 of a mil. 0.3 because the printer head is extruding 0.4, so we can't go much beyond 0.3. Otherwise, we're going to get spacing between, and then the thing's going to fall apart. So we can decide the layers, and then literally it's going to take your model and just go shoom, 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 up until you've got enough layers. And then in that, it's describing how to print out the ink or the plastic. Infill is if we are filling in a hole, trying to find something with a hole with something. Yeah, so on the side here, to make this edge, obviously it's not 0.4 of a millimeter thick, so we've got to make it thicker. So we go around it multiple times. How are we going to make this thickness? And that describes how we do this infill. So the infill then gives us our strength. So the less infill, more spacing in that wall makes it a weaker support, so it's not actually going to have much strength. If you go to 100%, then you're using all the ink in there, and you just go, it's like a child with a crayon filling in the gap, just painting everything. So you go for a happy medium. If you want strength, then you do the 100%. If you don't want strength, but you just need it to look right, then you go a little bit thinner. Supports, well, some of these models are quite complex, like this one. If I printed it this way up, so lying flat like this, well, actually, you might just be able to see there's a little notch here. So there's a problem, because if I try and print like that, the whole thing has to be on a support in order to stay upright. Yeah? So you're going to end up printing plastic, which you're going to print very thin and not try and adhere to this, and then you're going to have to peel it off and throw it away. So the goal is, for all 3D printers, is to minimize the bit that's thrown away, the rubbish. And so you often try and orientate your models or split them into multiple bits that clip together so that you minimize that wastage. And that's one of the key things. Now, when you put it into the slicer, it's able to pick an orientation, and it will actually often select the orientation that it thinks is going to be most optimal. So in fact, when I first printed this, it goes, we'll print like that. Now, on the face of it, sure, that'll work. No spaces, but because you're doing two colors here, you actually get a distortion in the text because it can't quite do it. And in fact, if you look on this one here, this one was printed that way, and you can see this is slightly textured and raised because of the way it had to switch between the print heads and so forth. So it didn't quite make the grade. But if I'd printed it face down, then it would have done a lot better. And then finally, the speed, how fast that head moves around. Now that is a nice trade-off between getting your print job done quickly and getting those layers adhesing properly. There needs to be a little bit of time for the plastic to cool down a little bit so it stays where you've printed it and it doesn't start following the print head around. If it follows the print head around, you end up what's called stringing, and you find all these little tiny filaments all over your print job. Often you can just peel them off and discard them, but it may ruin your prints if there's too many of those because they're obviously not adhering to each other properly. So it might be you just need to slow down, or you might need to redesign your model slightly so that those don't occur. So there you go, there's the popular slicers, Cura, Prusa, and OrcaSlicer. The slicer we're going to use for this one is a derivative of Orca. So it's all branded Kobra and Anycubic, but hey, it's all the same code underneath. And in fact, my Bamboo Labs uses exactly the same slicer, but they rebranded it with a different look and feel. So you can change them all around. And of course, there's nothing to stop me using my Anycubic slicer for this printer and point it at the Bamboo Labs printer and just describe how the Bamboo printer works. And if I know those details or pull them in from a library, then it will just work. So it is all cross-platform in that respect. Key slicer settings is your layer height, your fill density, print speed, temperature. Yeah, these things get hot. PLA typically melts at about 180 degrees. So that print head down here, this little tiny bit down there, will get to 180 degrees and stay there. Now, in my case, I actually print at 200 or 190, so I get a nice fluid flow. So I'm not just at that melting point. If we print something else like ABS plastic, that's 240 degrees. So don't touch. Now, this one heats up with a traditional electric heating element, so it takes a bit of time to heat up. My slightly more expensive printer at home, the Bamboo Labs one, uses induction heating, so it's instantaneous or near instantaneous, and boy is it quick. Very fast to heat up and very fast to cool down, so it makes that action very much quicker, especially when you're swapping heads, because they obviously cool down when they're not in the head. And then, of course, if you are using supports, where those supports kick in. So the slicer as it's laying out the model, and you say supports, it's going to then build up a framework of thin bits of plastic, sorry, to hold this up and allow that to print in that orientation. Now, what you can do is you can play tricks with how you design your supports. So you might say, well, actually, I do want supports, but I only need it right on the edge here. And so you can actually space out your supporting structure so that you don't fill this huge void. In this case, this angle here is currently 45 degrees, and so I don't need a support. It's just in the boundary. Sometimes I get when it's printing across here, it's laying one single strand that's 0.4 of a mil across from there to there, and sometimes you get a little bowing if it hasn't quite cut across sufficiently. But you just peel those off, and eventually it'll adhere and keep it going. So you can do it. And then finally, retraction. So when the print is moving between, say it finishes a bit over here and then has to start again over here, it will retract the ink back up a small fraction so that you don't end up with this dribbling going on as it's moving the head around, which will then distort your print job. So you retract the ink back into itself. G-code, so this is the actual code that describes the print job. So you could write your model in G-code if you wish. All we're saying is, well, G28, send the print head home. So don't matter where you are right now, figure it out, go home. So that, in this case, is there. That's the printer's home. so move it there. And then you've got G29, auto bed leveling. So that's, in this instance, what it does is it picks half a dozen points on the print head bed, so it moves the print bed around, and then it tries to lower down the print head until it touches the bed, so it can tell where the bed is. When it's then printing, if it's drawing a line and the print bed isn't quite level, you'll see the head moving up and down to marry up with the level of the printer. That is very new technology. I mean, they've only been doing that for 5 years, 6 years. Everywhere else, you'd sit here with 2 screws trying to thumb and the spirit level trying to level up your boards, and you're talking fractions of a millimetre. And it was a huge pain. They tried it with lasers, shooting lasers down, but of course we're talking fractions of a millimetre here, and lasers are accurate, but not that close. And so eventually they've got little pressure sensors in them to do that. But there are lots of different ways of leveling the print head. And then here we've got M104, set the nozzle temperature to 200 degrees. So basically turn on the temperature. Set the bed temperature, 140. Wait for nozzle temperature, so it's just going to hang here until that's done. And then here you can see we start saying the G, which is the actual extrude and move to draw your picture. So you could sit and type out all of this. It's just text. It's a big long text file that describes the whole print movement around. It's very well documented and very well used. So in actual fact, this printer is pretty dumb, because all it's doing is reading one of those lines at a time and performing that action. There is no brains in there per se to do anything else. So once it's on its way, it's off. Then we've got this printer. Those are its stats. So this one will do 4 colours. So this is what's called an AMS, which allows us to select multiple colours. Now in reality, this printer can actually do 8 colours. I can get another AMS and stick it on top. And then you change this bit out to one that's got 8 selectors in it. And then the ink just runs out through these PTFE tubes and down into there. So you'll see it, when we start it running in a minute, you'll see it pull the printer ink through. The downside of this one is because you've only got one print head, and you'll see this in a minute, every time it changes ink, it has to clean its head out. And what happens is it will retract the old ink, just a fraction, and then inject the new one, and it will keep squirting the new one out in this side bed here until enough of it's come through that the old ink colour is gone. And then it'll eject it out the back. And that's called poop, printer poop. And you'll get these little tiny curls of poop coming out. And that's it trying to clean those things out. This type of printer, if you have lots of colour shifts, so different inks coming through, will produce an awful lot of poop because it has to clean that head out every single time. My other one, because it has individual print heads, doesn't. It'll simply load each one into individual heads and then switch the heads out as it needs to do so. So it's a much, much more efficient. So if you're doing something complex with lots of different colours like this, I use the other printer and leave this one to do single colours or two colour prints more often than not. Okay, so today we're going to print out some name badges. So if you wish, I can print out your call sign on a little name badge with the Morse code on. I did mean to bring my badge, but I haven't got one. Actually, I might have it in the car. But anyway, it's just a little black badge with white writing with your call sign and then the Morse code for your call sign underneath. So we can print those out for anybody who wants one shortly. So I've already written the software to do this, so I will show you how that's going to work in a minute. But a few things to think about when printing. The key thing is that first layer of your print job. It has to stick to your print bed. If it doesn't stick, it'll shift all over the place and your print is ruined. So keeping your bed clean, just with soapy water, wiping it down every now and again, get rid of those greasy finger marks, is key to getting that first layer to adhere. And then, of course, looking to making sure your system is fully tensioned up, because if the head is slightly out, then it's going to shift as it prints the next layer and the next layer, and again you're going to get this step view of things not working. Warping is where if you've got the print head is too hot or too cold, then it's not again going to adhere, and then as the thing cools down, it's just going to sit and relax, and it's just going to bend and reshape itself. And we talked about stringing. That's if we're not pulling the ink back far enough as we're moving the head around to different layers. And then obviously if you're not pushing out enough ink, then you'll get this under extrusion where again you'll get gaps in your print and it just won't look right. You'll see it straight away. So they're easy to spot out. There's the couple of websites. So OpenSCAD.org, FreeCAD.org, and the huge community printables, Maker World, and Thingiverse are probably the three big ones that you go and find. And you can also find on those websites people that will happily print the pictures for you. So if you find a model you quite like the look of, you can probably find somebody that will print it for you for a small fee and just send it to them and say, print this for me. And in the amateur radio world, I'm finding more and more people with printers every day because they're just printing out lots of little widgets from guy keepers to rope winders to antenna parts, you name it, people are printing them out. I've printed out dipole centers, which is great because you just print it out, takes it maybe 20 minutes to print a dipole center out, and then off you go. So this is my code for printing out a badge. So I'll just go through it very quickly, but basically what we've got here is a bunch, a simple variable, name, so who's the call sign for, and that's all I need, because in this code it works out the Morse and then puts the Morse at the bottom for me, so I don't have to remember the Morse. The first time I was doing it, I was working out the Morse, and I went, no, let's do some programming on this. And then what we're actually doing is we're setting up two different print colors, black for the background and white for the text. And then here we can see we're taking the text that we want, resizing it to fit the size of the frame, so the size of the badge. And then we've got a function here, Morse, which takes the letter and then brings out the Morse. So we've got all the characters in there, and then there's a bit more entertainment in figuring out how to do what Morse letter is which. So if I open up so this is SCAD, and you can see there's my call sign. If I just change that to, so I'm just telling it to print or show all the colours. There you go. And there is my call sign. And I can obviously manipulate it around to my taste to see, have I got it all right? Is it looking good? And quick check, yes, the Morse is correct. You'd be surprised how many times I have to check the Morse, just to make sure I get my brain in gear. But there we go. So again, it's just a very thin plate of plastic for the base, and then the text is on top. So, would anybody like their call sign on a little badge?
Well, how about doing the new club call sign?
Oh, yeah.
G3CHR.
Okay, let's do that. So, what was it? G3. CHR. There we go. Okay. So we go G3 CHR. There we go. So all I've done is, on the command line, told OpenSCAD to make me, using my model, my call sign badge model, an STL file called G3CHR with the variable name G3CHR. So very easy to do. And now if I do open G3CHR, the STL file, fortunately, Apple knows how to open those, and there is the badge. All done. Now what we're going to do is, let me just change that to, was it 7, wasn't it? Yep, 7. So let's do that again. So just run that one again. There we go. So now, if I look at it, we just have the call sign, no backgrounds, because I've already got the background as a model. And the reason for that is if we then start up my slicer, which is the Anycubic slicer, I don't know if it's going to enjoy being at this very large font size, but we'll try it. There we go. So here we've got the slicer. Let's see if it will go full screen. Does that work? Just about. So down here on the right-hand side, we've got the bed, the print bed, and it models nicely what we've actually got. And what I need to do is bring in those models. So if I just open projects, there we go. So we're going to do a small badge, that's the background, and that is the foreground, the text. So just bring those two in as one unit. Yes, we're picking you in as a multiple object, and lo and behold, there is my G3CHR, and now I can pick what colours I'd like. So if I go to the object, which annoyingly enough, it won't let me scroll down to set the colours. All the way down there. Let's have a look, see if I can get to it. There we go, just about. So we set the text to be white, and we'll set the background to be black, like that. And then finally we say slice the plate. Here we get a little summary of the slice, including the print time. So it's going to take 8 minutes to print. So if I now save that onto an SD card, normally I'll just hit the remote print option, but we'll have to just export G-code file. Come on. There we go. And we'll send that to my SD, like that. And eject. There we go. So now we sneaker net it around to the little USB socket, and then on here we just say print USB stick pick the file, and you can even see it's rendered it on the screen there, and we just go print. Copying file, we can check the colours, so it's actually got the colours wrong because it didn't pick that one out. So if we just go back to there, we go that one, and I set the colour to white, like that, to white. There we go. And then go home, print that, and go there, select white, and print. And that's it. And you go back and have a cup of tea. So now it's just going to go and it's wiping its head, so it's heating itself up. So you've got a little bit of display information on there, and if I had my Wi-Fi, I'll obviously have the display information coming back to me. I have got a little camera on here as well, which is just a little USB camera, so I can watch it remotely and see that it's doing its thing. They have now added to lots of these things what they call AI. It's not bloody AI, but it's looking at the print job, looking for failure. So if you get lots of stringing or the print moves off and shifts off and it's not printing, it's printing into space, then it pauses and aborts the print job, rather than printing out a mass of crap and you come back home the next day and it's not printed out what you thought it's going to print out. All the plastics you want to keep dry. So in here we've got some silica beads to try and take the moisture out, and these AMS units all have heaters in them, so they can actually dry. So you can actually run a warming off effort into those to dry them out as well. If the plastic has got moisture in it, then you'll get this bubbling as it goes through the print head, and then it won't stick and won't work properly. So you do have to keep the moisture levels down. PLA is the most common one, which is a plant derivative, but they will do ABS plastic, so any injection molded plastic type things. This TPU, which is this flexible rubber stuff, and then now playing with carbon fiber filament plastic as well. So there's little fibres through it, and then conductive ones as well. So they're all playing with whatever else they can come up with. I've seen people print on top of cakes with edible icing, and there was a video I saw the other day of you could get your pint of Guinness and you put it up to the printer and it takes a photo of you and puts your face on the top of a pint of Guinness. So there you go. So it's now running out the black filament. We use this PTFE tubing, so it's low friction tubing to direct the plastic into the right place, and it should be just excruting it. So it's creating some poop at the moment. Now the first thing, when you get a 3D printer, do you know the first thing you have to print from a 3D printer? It's the parts for the 3D printer. So this poop catcher here, that's 3D printed. These top bits of plastic, you can print out lots of these bits to improve your print job. Often a little scraper to get things off the bed. Lots of things are then printed. The other good thing about 3D printers is they are all 100% end user serviceable. So anything fails on it, you can fix it. They are all documented, taken apart. This one I've taken apart, so I've replaced the bed on it, I've replaced the print head on it, I've serviced the print head itself all the way down into the individual bits. The circuit board underneath is all consumer swappable, everything. You can just replace bits and readily buy those parts to replace. So they... Yes, so this is the first layer. So down here, yeah, please. So the first bit it printed up here in the corner, that's what we call a tower. So because we're doing multiple colours, it's going to wipe as it changes between the colours, and it's going to wipe it onto the tower. So it's going to basically waste a little bit onto the tower. Yeah. You can barely see it, and that's with this little light on. Yeah, so you'll see it shoot across to here when it switches over the poop. Oh, there we go. There's the poop. So you get this wastage every time as it's changing between the ink heads or loading up the new heads it never doesn't remember what was in the head previously, so it always assumes because when the print finishes, it'll always retract the ink back again, and so it doesn't know that you haven't changed the cartridges, moved things around, so it'll always just clean the head.
So it's a single print head, and
yes.
this have to be...
Correct, yes. Yes, so all 4 are going to come, will terminate up to about here, and then when it wants it, it'll just push one through, and this just takes all 4 and brings out 1, which goes down into the print head and heats up and extrudes out. So it has to clean that bottom section. There you go, now it gets faster. So once it's done the first layer, it'll speed up, because it's trying to make sure that first layer beds onto the bed and stays where it's put. So now it's on here, there you go, we're 47% complete, layer 3 of 6, 4 minutes to run. So it's not too bad. You can see it rocks the table nicely as it gets up to... It's just a whole new world of capability that you can make something in your house without an awful lot of hardware. As I say, £300 is all of this, or £350 I think it was for the AMS as well. So you can have the printer on its own with one ink. The ink sort of sits up here and just drags it through on its own. And you can do that, and then you can manually swap the ink over. That gets boring very quickly, so you end up just getting the AMS unit, and then, as I say, you've got 4 inks in here, and so you can swap between all of those. But that doesn't mean that's the limit, because you can put splitters and dividers into this plastic here, and just keep adding and adding and adding more inks that you want to swap around. But normally what you do is you design your model so that you didn't do too many swaps, because, as I say, the ink wastage is quite high. There we go, so now we're pushing out the white. No, so now it's retracted the black back to here, and it's now pushing through white, which should have just come out on that tube here, and you can just see now it's going to start pooping out white as it clears its head through. So it will go. So you'll see this go from black to grey to white as it switches those colours through. There we go. Here's the tower now. You can see it's printed out a little bit of white on top of the black, just to make sure that the flow is right. And now you should start to see the call sign coming out. Yeah. But yeah. When I was first doing printing, the computer was actually driving the printer directly. So I had to have the computer on all the time, and of course, at a certain point, you go, "Oh, I want to do something else," and you quit the wrong program, and then the print stops. And there we go, we're done. So as it moves the print head over here, this lever here cuts the plastic, and then it allows it to retract the plastic back again. So it's left a small bit of plastic in the print head. So the next time the print comes through, it's just going to extrude that bit of plastic and print it out. But there we go. If I list this off, and there is your call sign. And we're all printing on these metal plates, which are magnetically stuck to the tray. But what it means is this is flexible, so I can just do that, and it pops off. So it does make it very easy to get them off again after it's done. And of course, because the bed is the size that it is, we could have printed out dozens of those at the same time and just filled the bed. Yes, it would have taken longer, but actually it would have been cheaper to do that, because you'd have less of this poop, because it would only change the head after it's done 10 of them at a time or something, rather than individually. Yeah, you can get pretty much any colour you want. The common ones are gold, silver, bronze colours, and then black. Everybody prints black and white, yellow, green, but yeah, no, any colour goes pretty much. The thing to think about when you buy your printer ink is, have they wound it nicely? Because you've got, I don't know how many miles of plastic in a run, and if they haven't wound it neatly onto the drum, it will tangle, or will have gone on tangled. And then what will happen is the printer will try and feed from the drum, but it will jam, because it won't be able to get past that tangle. Fortunately, these printers these days will freeze at this point and say, there's a problem, but of course, if it's 2 o'clock in the morning, you've got to wake up, get out of bed, and free it, and then hit go again. And it will carry on, it will fix. If you can fix the tangle, it will carry on from where it left off. So that's good, you don't lose your print job, but you want, it's almost worth paying a little bit more to get a good wound drum. Again, people are re-winding their own drums because some people really don't know how to wind the drums properly. And you think it's got to be easy, right? You just go drum to drum. If I show you, which one? This one here. So this is, if I take that out, that's the silica gel. So again, 3D printed that. That's in ABS plastic for high temperature, but it just sits in the middle and just gives the drum a bit of moisture eradication. And then we just, so most of these drums will have one of those in there now, just to keep the moisture out. So if I'm printing something like transparent plastic, then I will spend the day before, 24 hours before, heating the plastic drum to make sure I get a nice layout of that plastic. Same for TPU, which is the rubberized one. That has to be absolutely 100% dry. So you'll stick it in the oven, stick it in these things and let it dry out first before you print on it. Otherwise the print job will fail. And it will typically fail just when you've walked away from it, or it's about 30 seconds from finishing, and it will go and fail it.
Just remind us again, that model is a...
That's the Anycubic Kobra 3. Anycubic Kobra 3. And it's the Kobra 3 with the AMS, which is this plastic box. Now you can buy the box as a separate unit, but it's cheaper if you just buy all three together. And they're on Amazon. You can just go and order one on Amazon and it will be delivered tomorrow.